An electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field. The direction of electric field is now reversed, keeping its magnitude same. A proton is allowed to fall. See, this is directly from the textbook example. Just same question is there in the textbook, okay, but it has some data. Now it is given that, right, you have, let us assume this is electric field, and this electric field you are putting electron. So the electron will accelerate in the opposite direction of the electric field, and if you put proton, then the proton will accelerate in the direction of electric field. So let us assume between these two plates there exists an electric field. Okay, there exists an electric field, and if I put an electron here, then the electron will move upward, and if I put a proton here, the proton will move downward. And let us assume the distance they are covering between the plate is h. So in this question it is asked that the time of fall of electron in comparison to the time of fall of the proton is. It means how much we have to compare the time for the electron and the proton to cover the distance h, means which will take more or less time. Okay, so now we know that in presence of electric field, the acceleration produced in electron or a charged particle is given by QE by m. That is, the acceleration is proportional to 1 upon m. Right, it means the larger mass will accelerate less, right, and the lighter mass will accelerate more. That is, the electron will move very fast, whereas the proton will move slowly in the same electric field, because proton is heavier, right, because proton is heavier. Okay, so acceleration is proportional to 1 upon m. Now for uniformly accelerated motion, right, for uniformly accelerated motion, we know that y is equals to half at square. So if you make t as a subject, then t is equals to under root 2y by a. So here it is, t is equals to under root 2h by a. So from here we can say that the time of fall is proportional to, t is proportional to 1 upon under root a, and a is proportional to m, means t is proportional to under root m. Okay, you can put this value here directly. The value of acceleration, if you put here, then you will get directly this expression. Okay, because t is equals to under root 2h by a, just put the value of a here, 2h, the value of a is QE by m. So we can directly say the time of fall is proportional to under root m, that is the mass of the particle. So here the mass of the proton is more, so it will take more time, and mass of the electron is less, so it will take less time. Right, now the proton will take more time to cover the same distance. Right, so here the time of fall of electron is very less than the time of fall of proton, hence the option A is correct.